All right, so we talked about certain displays of the quantitative data, and we're going to keep up with that today. So one of the most common, I would say, is to use a stem and leaf plot. All right, so a stem and leaf plot. Now, the data that we have is this monster of a table. It just really depends on what kind of data you're given, how to put together your stem and leaf plot. All right, so notice in this one, we have decimals. So when we have our decimals in this particular stem and leaf plot, we're going to make our stem the whole numbers and our leaves become the decimals. All right. Now, when I make a stem and leaf plot, so all of your data, when I'm going to give test data, and your test data, I always put in a stem and leaf plot so you can see what everybody's test scores are in this format, right? No names are associated, obviously, but it's just the data being represented. When you make up your stem and leaf plot, I do the first one where I just collect the data, but in order to have a legit stem and leaf plot, it has to be in order. So your values have to be in order to make it a legit stem and leaf plot. That's kind of the key to that. All right, so let's look at this. We have 16, 11. What's our smallest value? There's a 9. There's a 7. Anything lower than a 7? Doesn't look like it. So 7, we're going to take 7 up to what? What's my biggest number? There's a 19. Is that the biggest number is 19? I think so. Unless you're seeing something I'm not. But I think 7 to 19 is where we're going with this. So I'm going to make 7. I'm going to squeeze this in so we can see it better. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And that is our stem. So if I have this like 16.9, that means 16 goes on this side and 9 goes on this side. And that's how we're going to lay that out. So right now we're just going to put these in order. So 16.9, I'm going to put a 9 over here. 11.1, 14.9, 16.4, 13.3, 10.3, 9.6. And so this is just tedious. So you should be doing this at the same time I'm doing this, so that you can be checking this out together. Now, notice this is a 14.0. You have to put a 0 in there because you have to have the same number of data points in your stem and leaf as are on your data set. All right, so yes, you have to represent that one. 14.9 again. And if it's the same, that's okay because you have to represent all of them. 12.8, 12.6, 13.5, 10.7, 11.9, 17.2. Just staying organized is the key here. 19.7, 11.1, 9.3, 10.5. So I'm just putting the decimals, and those are my leaves that are going out. Do you see what's happening here? 9.5, 19.8, 13.4, 12.5, 10.8, 13.0. This one's kind of a big one. I'm not always going to give you these great big huge ones like this. 19.7, 14.1, 14.7, 10.3, 14.0, 15.8, 13.2. It gets a little tedious. 12.5, 11.6, 15.4, 13.0, 15.0, 14.7, 9.7, 11.3, 10.6, 11.0, 19.1. Hang in there, we're almost done. 11.3 and 11.3 again. Okay, so here is this mess. So I'm going to make this bigger because now we have it. Now you can always check and make sure. What did it say? How many do we have in our data set? Oh, it doesn't tell us. So let's see. We've got, oh, it's all the different states, right? Is it every single state? So 50 of them? Yeah, so then we should have 50 pieces of data. You can always count those to make sure that you're in good shape there. All right, those are just in alphabetical order, but if you've got your 50, then you can count out 50 to make sure you're good. Here's the key to stem and leaf. Leaves have to be in order. So if I were trying to throw down this particular stem and leaf plot, you're wrong, right? This is a bad stem and leaf because this is 6, 5, 3, 5, 7. Now, that's not in order. So when you do an actual stem and leaf plot, your leaves have to be in order. All right, and it's good to have a title that goes with this. Percentage of persons living in poverty. Of persons living in poverty. Man, my handwriting is really bad, you guys. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So then you put them in order. Now 7 just has a 7. Now here's something else. When you line these up, it is good practice to try to keep them in columns as best as possible. So there's nothing for 8, but for 9, you've got 3, 5, 5, 6, 7. So 3, 5, 5, 6, 7. 0, 3, 3, 0, 3, 3, 5, 6, 7, 8. 5, 6, 7, 8. Notice you're still just putting them order. You're not trying to put it in order of, like, you don't have to line the 3s up or things like that. But notice this is a column, column, column. And we're going to try to keep that the same all the way down. That helps keep it uniform so we can actually see the distribution of these as we're looking back through it when you need that. So 0, 1, 1, 3, 3, 3. 6, 9, 5, 5, 6, 8, 0, 0, 2, 3, 0, 0, 2, 3, 4, 5, 6. 14 is 0, 0, 1, 2, 0, 0, 1, 2. Notice how I'm trying to keep them in columns. 7, 9, 9. And that also helps with the distribution. How far out? How much of each one? 4, 6, 9. That's a 2. There's no 18s. And then I have 1, 7, 7, 8. As we're looking at that one. Boom. There it is. That is your stem and leaf plot. All right. This one had a whole ton of data in it. So it just depends on how much data you have, what it kind of looks like. This one had decimals, so we worked in terms of decimals. A lot of times, I'm going to scoop this up so you can see what's happening here. A lot of times, if you just have 2-digit numbers like this, you can say, oh, here's the tens digit, and then you've got the ones digit. And notice these are in numeric order, and you repeat whatever it is. If you have a certain number, then you repeat that, right? So this is a tens digit. Now here, if I'm like, holy cow, there's a ton in that tens digit in that one. So you can break it up. So this first one is going from 10 to 14. And then the second bit is going from 15 to 19. So you can break them up. Also, it's called a split stem. So you can split those stems up so that you can see kind of how that all plays out. If you want something that's not quite so cumbersome. As long as you say what it is, that works too. One other thing that I'm going to put on here that, oh, I ran out of room though, didn't I? But I'm going to put right over here off to the side. You can also have a double stem and leaf. So you can have 1, 2, 3, 4, and then you can have 2 different sets of data. Let's say I want to determine what's happening. I'm going to make this bigger with men and women, right? I have some data, who knows what it is. So this is going to be like 12, 17, 18, and this is going to be 10, 11, 16, right? And 21, 22, and 28, 29. So when you do this double, 1, 7, 9, 2, 4, 8, 3, 6, 9, 1, 1, 6, 4, 7, or 9. So whenever you do this, when you do your double stem that comes off of this stem, it's always out from the stem. So notice this is 0, 1, 6 because it always goes away from the stem. Just like a tree trunk, you start in the middle and then you go out from there. You start at the stem and your leaves go out. All right. And you can do 2 sets of data. Sometimes you do that because you want to compare them. All right. There wasn't an example in the book like that, but I just want you to be aware of that kind of situation. So lots of different ways in order to show out the stem and leaf. No matter what, all your leaves have to be in order. That's a key to the stem and leaf.